Hi class. The last statistical technique that we're going to talk about is regression, or more specifically, multiple hierarchical linear regression. What that means is that, in this case, the regression is going to be done only with continuous variables. So all of your variables, both dependent and independent, generally think of it as they have to be continuous. In addition, regression is a lot like correlation, but just building on it and making it bigger. So it has a lot of the same constraints as correlation has. That is, there's the assumption that your data is normally distributed and that the pattern between variables is linear. A regression has a dependent variable, and sometimes we refer to that as the criterion variable, and one or more independent variables that we refer to as predictors. So in this case, much like the two-way ANOVA we talked about before, if you have a more complex model, if you have a more complex idea of how different factors influence some outcome, regression would be better than just doing a whole bunch of singular correlations. You could take a whole bunch of predictors that you think influence some outcome and see which one is really the best predictor, controlling for all other variables in the analysis. So if you look at something like academic performance in children, what influences academic performance in children? Well, one thing people always think of first and tend to want to tinker with the most is teachers and teacher performance. There's a huge amount of things going on now in terms of statewide tests and evaluating teachers on those tests and how children do on that performance. So one thing society tends to think influences children's performance in school is the teacher, but also the school itself, the resources that the school has, the way that the school is structured, the school environment. These are things we know relate to academic performance. How about the family? The family and the way that the parents are involved or not involved in the school and in the child's education certainly can make a big difference in how the child performs. And you can probably think of a whole other host of factors. Each of these are important, probably. Are they all as important as each other? This is what the regression would help us figure out. Maybe something that looks important, we're always thinking, oh, teachers and the way the teachers teach is the most important. Well, maybe you put it in a regression equation and it's going to tell you how important is the teacher in comparison to all those other variables. And one thing you can do with a regression is also to assess how well all of those variables actually predict variability in the outcome. So if you have variability in academic success for children, some children do very, very poorly and some children do exceptionally well. There's variability in academic success, and there's variability in the independent variables, the predictors. So there's variability in how involved the parents are in the child's schooling. There's variability in how well a teacher actually teaches. There's variability in the amount of funding and resources that a school has. So you look at the amount and variability of those independent variables and how well together they all explain variability in your outcome. How well do they explain the total variability in your dependent variable? So if you have academic success of children, how well do those variables in the model explain together academic success in children? So you can have a model with 3 significant variables that actually very poorly explains your outcome, or you can have a model that fits very well, right? Goodness of fit, a model that explains a lot of the variability in the outcome. So say you loaded in those 3 variables, school environment, teacher, and family involvement in school, and you had an R-square value that was 0.54, it would tell you that those 3 variables together explain about 54% of the variability in a child's academic success. About half, so that's maybe not so bad a model. If it was around 0.15 or 15%, you would say, well, those variables are significant, but the model is not very strong. It's not a terrific fit. So the R-square value really allows you to evaluate how well your model is explaining the outcome or the dependent variable. And again, like with correlation, for the most part, your variables have to be continuous. You assume normality and distribution, and you assume a linear relationship between the variables.